Welcome back, everybody, to Selling Circular. My name is Gar Punnett, and of course, I'm joined by
Sabira Lakhani.
Excellent. I'm the founder of a company called Loop Layer, where we are looking at reimagining the remanufacturing revenue streams by just thinking differently about how we bring new products back from their useful life cycle to try to remanufacture them. And of course, Sabira is from the, well, legendary, at this point, I would like to say, the legendary Repley.
Yeah, I'm a senior director of product, been with Reaply for 3 years, and we sell enterprise software for large organizations and now organizations of all sizes to be able to track what they've purchased so that they can best reuse what they've purchased at scale.
And with a big announcement too, with the drop of the New York City materials marketplace. That's pretty huge.
Yeah, I don't think we call it materials marketplace
You
though.
don't. Yes. Please tell us what you call it.
I believe it's our Circular Cities initiative, which is
Perfect.
gives the opportunity for a sponsor to help unlock the circular opportunities between organizations in a city. So you could imagine, two organizations, one has surplus, one needs a bunch of stuff. How can they connect, exchange items, goods that are second life, and then track that over time and measure and report on it as well.
And so, of course, one of those important items is wood, which seems to be a continuing topic for us here, which is
Yeah.
just as important it is to find the market for wood, and those that are interested can do that through Repley's Circular City initiative. But we're kind of still in the process of discovering how to reclaim that wood. And in our last episode, we were talking, or I was talking, because you actually had a previous engagement. We can maybe talk about that at some point. But I was talking with an organization with the Green Mission, with Jessica's episode, in which she was talking about how to reclaim or how to properly appraise wood when it's being deconstructed, in the process of which you can again appraise the value and then take that off in terms of a tax benefit. And that set us on a little bit of a path here where we then now got to talk to and set up an interview with Eric Law, the CEO and co-founder of a company called Urban Machine, which we will dive into a little bit when we get there. But this, again, set us off on what we wanted to talk about today, which is how and why it's so difficult to build a business model that is trying to innovate itself out of maybe a pervasive or what we call maybe a wicked complex problem that has a lot of issues from a lot of different angles and requires a lot of innovation, a lot of collaboration to solve those. In this particular field we find ourselves in, that's a circular product offering where you're trying to reclaim a commodity and then trying to essentially make sure it lives up to the standards of a new commodity, but it's still reused. And so you have to either, really, my point in this, and I'd love to hear your take, is you always have to build solutions that are either layering on top of existing business models, operational models, and we can talk a little bit more about that, or you have to outright outperform the new product and just be better than new.
Yeah, and the reason for that is if you're on the demand side, if you're looking to use wood in construction or in any product, as a consumer of that commodity, you might place a little bit of a premium, maybe an environmental premium, a carbon premium on using Second Life or reused commodities, but you still need it to perform in the same way as if you were using a new piece of wood, especially if you're thinking about using it in construction. And so, what you're talking about, Gar, or maybe even hinting at, is the in the value chain, whoever is doing the work playing middleman between the supply side and the demand side has to provide some sort of value or service to make or unlock the second life wood's possibility to be just as good as new, so that the
Yes.
demand side has no qualms about buying second life.
It really comes down, and we get this, I think, into a little bit of the episode, which is risk mitigation. And so much of what we're doing both now as we work on the enterprise space is it's so easy for us to think, oh, as a consumer, of course I might want to go to that local reuse shop and buy that wood. But that's a very easy decision in a low barrier of risk for a home consumer to make. But at the scale of which we're talking about larger enterprise, larger construction companies of which they're operating and trying to service, that comes at a significant volume. And with volume comes an aggregation risk of whether you can pull enough volume in to service the need. But also, when you're aggregating all that material, is it of uniform quality and consistency of performance when it's being used to construct or to frame or to do the function that it needs to in the construction application. And so ultimately, that is the challenge: is how do you do this? And sometimes, as we've seen, we wanted to talk about how old is better. We were both talking, getting into it in the last episode, but then we get into a little bit today is why is it, as a reminder, why is it better? What did we learn with Eric? And we actually get to see it coming up, but why is it better?
The old wood has more growth and basically like scientifically like tighter rings in the wood
Right,
that makes it
exactly.
sturdier and more reliable, even more beautiful, like
Yeah,
from a
I think
visual
aesthetically, yeah.
perspective. And that's it, not necessarily that older is better, but there was a certain quality to the older wood that is better than the wood that has been grown today. And that's really when I think about the the folks in the middle between the quote unquote supply side of deconstruction and the demand side, each material is going to have its different economics, its different uh, logistics and aggregation economics and processes. It's going to need different processing. It's going to need different sales tactics. So really like the there's a huge opportunity because like you were talking about old might be better in wood, but that might not be, there might be different characteristics about the
It's
next
true.
material.
Yeah.
And that's really interesting and fascinating because like there's a lot to learn there.
I think, yeah, you're right. That, when we're talking about, it's very easy to talk about one very specific, even type of wood, and then very specific commodity category. But when you're talking about a construction project, uh, that becomes very different. And trying to accommodate reuse can add an exponential amount of complication to a project planning, let alone potentially a cost. And so that is the challenge. That's what these service providers that are creating these circular product offerings are really trying to innovate, is how do we make this just as easy to buy used as it is to buy new, when our whole system is built on that linearity of new products. I wanted to return quickly back to maybe we can repaint the picture for what the process is like in terms of deconstruction, because I think this is where Urban Machine will layer on top of this. Is we learned about a consumer, a homeowner or a business owner making a decision to deconstruct a home. That means you're bringing in a team whose expertise is to deconstruct. You're not relying on a demolition, which might take a quicker amount of time, but you're now relying on that expertise of that team to take apart that structure. And then up to that team is now to properly sort on site. And can you talk a little bit about what we know from recycling and sorting on site, and how that might equate to what it means to sort on site and why that's so important?
Yeah. I think so when I lived and worked in India, we provided this service to large technology parks. where, your KPMGs and your Goldman Sachses of the world, right? All their employees live and well, they don't live there. They work there all day. Their work life is there.
Practically living, but yes.
Practically living. And so all of their waste would basically come down to us throughout the day, their organic waste and their inorganic waste. And the manual labor that we provided as a service to these tech parks was to have people basically open up bags of what we call dry waste, right? The inorganic waste, and physically, like visually recognize, oh, that's paper. Paper goes in this category. Plastic, that goes in this category. Oh, now there's three types of plastic. I need to sort that further. And you try to get like with like as much as possible so that you can get volumes so that you could sell the volume of like material to a processor, a recycler who's aggregating from many different tech parks in the city to get kind of the best economics and the bang for their buck. And they are seeking supply as a processor. And so that very manual work depends on the knowledge of what the materials are, what the qualities are. In the world of recycling, like the level of contamination, what's allowed, so there's thresholds. And it's all really interesting because manual work in India, the economics of that is totally fine. But in the
Right.
US, that's less viable. So there's also a ton of opportunity. I know there's some AI companies out there that are trying to, use computer vision and then help recycling companies sort through whatever waste comes to them so that you don't have people actually doing manual sorting.
And I think that's what maybe people forget, an audience might forget, or anyone who doesn't really study the recycling markets is, and I like how you breezed over just a little bit why that model makes sense in India is because it's a labor cost, and so that's why it does make sense. Is
Mhm.
um, there's a different labor expectation and policy set here of what it costs to use a human to sort through that recycling, and ultimately, kind of to your point, humans can make a good recycled product because they can discern what should go where, and
Yep.
they can make like and like happen. Um, I think we're just getting to that. To your point, there are great companies, and maybe we can talk about them coming up too in other episodes that are starting to sort through and use these arms with suctions or different gripping technologies to pick through that. But ultimately, it's still augmented by fingers, and fingers are probably still the prevailing method through picking through recycling and finding that value. I should be very clear: human fingers pick through this. So our
Yeah.
recycling systems are only enabled by people still. I mean, that's really what this comes down to. And so when we talk about aggregation, how important it is to aggregate or aggregate and sort at the source makes downstream aggregation and grouping these materials together all the more important and all the more likely that they'll find value in these secondary markets. And secondary markets can be anything from a reuse store, again, which we've talked about, to a Repley circular city marketplace where someone might be able to buy a load of X amount of commodity product that's been deconstructed. So whether it might be certain type of fasteners, that used in whatever application for construction, or wood itself, or any other product that might be pulled from, aggregated, and sold. In that aspect, then, what is very interesting is when we talk about that secondary market, it's always competing with a new market. And I'm going to turn to you again to talk about a little bit about recycling and the complications that the secondary markets have because they're always competing against new product.
Yeah. I know that when we were, oh, this happened a lot in plastics was
Yeah.
the quality, and it's frankly in all materials, but we saw the economics fluctuate more in plastics, sometimes paper, but you would have, because there's different qualities of plastic, thicknesses, and basically potential for processing and reuse. Even with like colors, if you have clear plastic, it's more sellable than plastic that has color in it. that would definitely drive the end markets and whether or not, they're willing to pay a premium because of how uncontaminated or clean the source material is. And, the source material is still very much used water bottles that may be contaminated or cleaning bottles or whatever plastic you can think of. Now, that would also be more complicated or impacted by the price of oil because as the prices of oil drop, then manufacturing new plastic would become cheaper and cheaper. So anybody who's assessing, should I buy new plastic or recycle plastic as my source material for whatever I'm going to manufacture, they would always just have this economic choice to be making of comparing the two. And so you would see kind of like what our sales would be highly impacted by these other market dynamics. So it's not so straightforward that I'm going to go out, find the source material, and I'm going to find a buyer for it, and I have a business that works. There's all the surrounding kind of economics
Yep.
influencing the recycling market.
One of my favorite findings I did in some research when I was researching back in grad school, the plastic markets, was all about when a purchaser, someone who's procuring from a supplier of plastic, whether recycled or new, the consideration came down to, yes, sometimes it was purely economic. And they would go to that market and say, hey, I really want to use recycling, but it's not within this essentially equation I have for how close it needs to be to the virgin plastic material. And I had some contact quote me and say, I'm not willing to purchase a recycled product because it would require me to change my machinery. It would require me to change a
Mm,
little bit of my processes. I'm not willing to
hmm.
purchase it until it's 20 cents below what the new product would cost. So I imagine that's changed to some degree. And I mean, that research was 7 years ago now. And so ultimately, the market's changed dramatically, but still, that consideration's always there, is what processes do
Yeah.
I have to change in order to make this happen. And we actually saw that in our first episode with Lime Loop, actually, when I talked with Chantal, which is she was dealing with the same types of considerations, which is people not wanting to switch from boxes because it would require some machinery shifts, it would require some capital investment to shift to reusable containers, reusable shipping strategies, and that would require some operational shifts. And so there's costs always involved in this switching. And so that again is where, when we get to costs, well, the equations kind of changed during COVID. And this is where it got very interesting when it came to reuse, because ultimately the new product started costing about 4x what it was pre-COVID to what it was during COVID.
And
And the
you're
prices,
talking specifically about wood.
and I'm talking, thank you, very specifically about wood. And in this case, some of the research I was doing in terms of plywood was, it went from being about $400 per square foot to $1,500 per square foot, which for per sheet would come out to roughly something in the going from 12.80 to about $48 if you were to walk into Home Depot
Mm.
and buy this. And so ultimately during COVID, there was a huge, and we all heard about this, whether it was toilet paper, whether it was, which probably had something to do with some, again, supply and demand, but also wood. But again, this idea that there were supply chain shifts and demand increases and spikes, but also then shortages. And that's where reuse started to look pretty good, is you could actually maybe deconstruct a building and start to get wood that was very much now commercially competitive with this new product. Even though I'm sure people were still getting their margins up by selling at an increase, but still, that's where people really started to turn heads and say, oh, there might be something to this reuse aspect to when our supply chains get a little wonky.
I love that because even though that was a painful moment for anybody trying to make the home that they were stuck in more beautiful, is that the increased price of this commodity unlocks and accelerates the investment in infrastructure to be able to process the second life commodities, and in this case, wood. And I think Eric's story is so interesting because not only do you have the market price of the commodity itself, but you also have in parallel this other industry trend happening, which is the cost of AI and computer vision coming down and being more accessible, such that he could leverage both of those things at the same time to experiment with, hey, can I build some technology that could recognize what processing needs to happen for the wood so that I could sell it? And all of those numbers kind of sounds like they aligned so that he actually has a viable process layered on top of the product of the wood itself to get it to be just as good as new.
And I think you've set us up well with talking about what Urban Machine is trying to build and becoming, even bringing up the AI pickers and the machine pickers from a recycling aspect of what they're identifying. That very much plays into what Urban Machine is building. It is using hard tech in terms of robotics and combining that with a machine learning, artificially intelligent type of software component that is able to identify imperfections of metal that might be lodged within wood and ultimately pick out those metal bits, and then out comes a serviceable, usable type of commodity wood product that can then be used in a project. Ultimately, what we start to get into is the business model of the business. We start to get into the strategy of how to deploy some of these urban machine containers. And Eric really dives into ultimately what makes the business really, I think, what we think, you and I both, the business of the future of really trying to not have people be the focus of picking out elements of these metals, these fasteners, but ultimately, what can we rely on in terms of machinery and software to help do this job and make this commodity more reliable? Thank you, everybody. I hope you enjoy the interview with Eric Law of Urban Machine. We're going to get into it right now.
He's great.
There's a hard tech component to this and a software tech that I think is very unique for a circular economy solution, a sustainability solution. You don't find this very often. Could you, in your own words, really help everyone understand what it takes to be salvaging the past and build that future through Urban Machine?
AKA, how did I trip on this problem, right?
Exactly. We can start there and then we can move right into what's the actual solution.
Absolutely. So, yeah, at Urban Machine, we're focused on reclaiming the 37 million tons of dimensional lumber that gets thrown away here every year in the United States. And it's not just a US problem, this is a global issue as well. We've been building with wood for hundreds of years, and the current source for all that wood when a building comes down or gets remodeled is either an incinerator or a landfill. Maybe a little bit goes to landscaping, a few odds and ends projects, but most of it does not get reused, which is not a good thing. And when I was doing some research into this problem, when I came upon it, first I figured out how big it was, and it's like, wow, that's massive. And then the second one is, why aren't we reusing this material, right? Wood is this high strength natural material. It's the predominant building material in our residential construction and low rise commercial as well. And what I found it was the fasteners. The fastener companies had done a really good job over the years developing metal fasteners to hold the wood together in our buildings. And it was just too laborious to pull out at scale, right? You couldn't put 400 people on a process line to manually do this and make money on it. And so I think this is a perfect opportunity for machines, right? It's a repetitive process. You're just doing it over and over and over again. It's a high volume process. It's a lot of fasteners that has to come over out of this material. And so it just set itself up as a problem to be solved with a hardware software solution.
Can you break it down even further, the types of fasteners we're talking about lodged in each one of these pieces of wood that we might find being deconstructed or just existing in our structures?
Yeah, so the majority of what we see today in the waste stream is really nails and staples. Those have been the predominant fasteners for the last 100 and something years. We're starting to see more screws come in. Screws really took off, I think, late 80s, early 90s with the battery operated drills that start to expand. But most of what's coming down today that we see is really a lot of nails, a lot of staples, and then you get some unique MEP fasteners in there as well. But for the robots, they're very focused on nails and staples.
And then one more question before I yield to Sabira here, which is you mentioning that repetitive aspect of maybe a motion, a task is almost uniquely suited for a robot and any sort of software accompanying that robot. Why is that the case? Break down the actual technology or the habit, I guess, or really the function that the robot uniquely serves in that.
Yeah, robots are great at doing the same thing over and over and over again, right? Humans like to solve problems, and most humans prefer that problem to change, right? If you think about like a laborer working in the field every day, they're probably going to do something different. They may be always building a building, but they're going to do something different or a different task each day. These machines, every single day, they're going to pull staples, and every single day, they're going to pull nails. And if you put a human on that and you try and get them to work there, 40 hours a week, 4.5 weeks a month, they're going to go nuts. You got to rotate them around to different tasks. And in this particular application, we don't. And so this is a great task for robots because what they're doing is they're using computer vision. Essentially, they're taking a picture of the wood, they see the staples, they see the nails, and then they go pull it out. And they repeat. And they repeat that over and over thousands and thousands of times a day per shift. They don't get tired, right? They're not looking for something different. They're not really solving a different problem every time. It's the same problem, just that staple's orientated differently each time. And so the cool thing about this is we're not taking anyone's job because nobody's doing this at scale today, right? There aren't hundreds of thousands of people out there pulling nails and staples every day, at least not willingly, right?
Right.
It's definitely not a task anyone wants to do. And so we're bringing technology in to solve a problem that nobody's solving today. And then what we're doing is we're creating a local supply of raw material. Because once the wood is metal free, now you can plane it and mill it just like virgin wood. And so all this material is coming out of major metropolitan urban centers, right? So think about like LA, Texas, right? Phoenix, Arizona, all these places far from the trees suddenly have a raw material of wood that they can, instead of burning or throwing away, that now creates a raw material to feed a new economy. And so that economy can be wood manufacturing businesses, it can be furniture, it can be building components, it can go back into the local ecosystem to solve, local problems.
I love that you already kind of clicked on both the supply and demand side of your business. So tell us about how you acquire the wood. Like at what point in the deconstruction process do you get your hands on it? And then are you directly selling to furniture companies that might want to use this wood or other building materials or building material companies or contractors? What's the flow of the wood?
Yeah, so we have two sources of the material. We definitely prefer deconstruction. That gets us the highest quality material, the highest volume material when they deconstruct a building versus demolish the building. Unfortunately, today, that's not the majority of the way buildings come down. Most of them still get smashed up with a machine. But that still provides us a lot of material. And so on the waste side, we work with demolition and deconstruction contractors to source directly from them. And then the secondary step is we work with the waste processors. So if we can't catch the big contractors taking down the big buildings, then we work with the waste processors where essentially they serve as an aggregation station for all the smaller contractors, right? Think about all the pickup trucks you see heading down the road, all the contractors with the trailers and trucks loaded up. They dump at these waste facilities, and then we divert the lumber from there into our machines. And so that becomes our raw material. And so today, whether it's a waste facility or a contractor, they're paying to get rid of that material, right? They pay tipping fees to dispose of it. And so the partners on the demolition deconstruction side and the waste side are excited to work with us because what they want to do is take a material that they have to pay to get rid of and turn it into a revenue source. And so the material we get today, they don't charge us for it because they want to see us succeed and change it. And it saves them money, right? Every dump truck we take is one less to the landfill or to the incinerator. So it's a huge win for our raw material partners, the demolition, deconstruction, and waste facilities. And then once it's cleaned up, today we're in the wood business, right? Because in the supply chain, the waste industry is not connected to the lumber industry. So we're using our technology to solve that problem, move that material. But long term, we want to connect those two. So an intermediate step is we're going to connect the economy and the supply chain there to move clean waste wood from the waste side over to the lumber side. And that can go to lumber mills, it can go to furniture manufacturers. Anybody that's used to working with virgin wood can take this reclaimed material and turn it into finished products.
I have a quick follow up on that one, then, Sabir, which is we will have the luxury in the video component of this to edit in what the actual machine looks like in real time. I've had the pleasure of being there in person, showing it or seeing it being demonstrated. Could you verbally explain this? I mean, what paint that picture for someone who is listening to say, okay, what does this actually look like? And they'll Google it and they'll see it, but ultimately, it's a very unique process and a very unique solution that is container sized. And I would love for you to kind of talk people through what that actually looks like.
Yeah, so that's a great example, guys. Take a look at a small container, right? So it's about 6 feet wide, 8 feet tall, and about 6 feet deep. In this box is a series of cameras and robotic end effectors that are racing around quickly with claws on them to pull out the fasteners, right? We call it our big bird. It's like a bird beak is sitting in there just literally just pinching away at the nails and the staples to pull them out of the wood. And there's four of them in there running, and cameras are taking pictures. So you're seeing flashing light inside this box, taking pictures and pulling the metal out, and then you hear the pulling sounds. It's pretty cool. We'll get you some video on that of when it pulls a 16 penny nail out of a 2x4. And it makes this really cool sound. I don't know how to reproduce it yet, but we'll share some video with you for it. But it's awesome. And it's very gratifying, watching it. People, we host tours of our facility and the machine for people to come see what we're up to. And people are like, this is really cool just watching this machine continuously chunk away at getting the metal out. And then once the wood's out, it goes through a giant metal detector that's about 10 feet long conveyor with I think it's about 6 feet tall as well, and about 4 foot deep, chunk of coil to make sure we got it all. Right. That's the most important criteria our customers have is making sure we got the metal out. So I've got, state of the art robotics with lights flashing, and I've got an old school metal detector coil. Right. And so I brought those two together to solve the problem and make sure we're doing it right.
I'm curious, how often does a metal detector go off?
Right now, it goes off a fair amount. One of the things about AI is you're training it, right? You're constantly training on new fasteners, new orientations.
Hmm.
Every batch of wood we get in, there's a different orientation of the fastener, and maybe it's covered by some drywall paper or some roofing paper. And so we got to keep training the software. And so with each new batch of wood, off goes the metal detector. And then after we've processed, a couple hundred pieces of it, and it's gotten smarter, and we've gotten the images tagged, then the metal detector starts to get quiet again. And then a new load of wood comes in. And so one of the things that we have to do is just run a lot of wood from a lot of different waste facilities to build up that data set and that knowledge in our software platform.
That makes a ton of sense. Do you find that the buyers of the waste wood or, reclaimed wood, what's their attitude or thought process around using this as a source in whatever they're going to use the wood for? Do they have any hesitancy? Are they excited about it? What's their feelings?
Everybody's excited at first. Everybody's like, well, this is cool. This is a great green story. It's low carbon. It's reclaimed. Absolutely. And what's always funny is we're like, well, just keep in mind, this wood's been used. It's higher quality. It's a thicker grain or tighter grain on it. But it's not going to be smooth. It's going to have nail holes in it, right? There's going to be staple marks. There's going to be things like that. And so we've had a couple examples where we work some designers on some big commercial projects, and they're like, "Oh yeah, we want to use your wood." And so we give them the samples and the submittals and stuff to submit to the client. And then the client and the architect, the very first thing they circle is the nail holes on the submittal. And we're like, guys, this is reclaimed wood. You're going to have nail holes. That's the whole story you want to tell with the building. It's not going to look like a brand new piece of virgin wood. So it does take some education, right, to make sure that people are aware of you can't just have the story without the images and those physical nail holes in the wood. But some people recognize it and they love it, so it's just a little bit of education there.
I love thinking of those nail holes, the marks, the scars are almost the proof against any greenwashing. Like it's the
Exactly.
proof that again, no one put in this mark.
Yeah.
This was used. It was used previously. We reclaimed it, and therefore it's almost that badge of honor for that design and maybe that piece of work. I'm actually going to take us back real quickly to a question that Sabira had too about where in the supply chain probably is the machine placed. I think I would love to learn a little bit more about because we're coming hot off of an episode where we're talking about deconstruction and lumber and the value of that lumber. Where do you all in both see now where this machine is placed physically,
Mhm.
and where do you envision this machine being placed in the future, where the physical location is so important to the aggregation and then separation and then ultimately the reclaimed ability to this wood through the machine? Talk about the physical place right now. Where do you find it to be most successful?
Yeah, so right now the first one is up at a lumber yard, about 45 minutes here north of our offices in Oakland. And so we chose that because they're a phenomenal partner and they let us store material up there. So for 6 months before we brought the machine out in the field, I was collecting material from demolition contractors and we picked up, 6 or 8 truckloads of material that we stored up there. And they're like, hey, here's the space. We got room for it. And the trucks can come in and get unloaded. So that worked out great. So the machine's up there, it's getting dusty, it's getting dirty, it gets rained on, it's running its paces, we're breaking it, which is what we have to do at this stage. And we're learning a lot from it. And that's all going to the next iteration. And one of the things we learned early on is originally we thought we'd have these central collection facilities, all the trucks would come, dump it at our facility. And one of those trucks dumped inside our shop and the wood went rocketing across the floor and hit one of our early prototypes. And Andrew, one of my co-founders, and I looked at, we're like, okay, we need a new idea. We cannot have these in a central facility. This moving reclaimed lumber with nails, bolts, and staples sliding across floors coming out of dump trucks is not going to work. So what else can we do? And so that's when I said, let's make this stuff portable. Let's go to these large job sites where these big dump trucks are. If you're taking down a 50,000, 100,000 square foot warehouse, let's go operate there. So the demo contractors today, they take down the buildings, they put it in all the piles of wood and concrete and steel, and then they grind up the wood and they grind up the steel and do all that and recycle it. And we said, hey, let's replace the grinder. Let's put our machine there next to that wood pile. We'll clean the wood here and then we'll ship it on flatbed trucks, just like virgin lumber. So that's the most efficient scenario we've come up with, right? Get us real close to our raw material source, clean it up there so we can ship it on flatbeds versus dump trucks. Works much better, but we can't do that everywhere. That works for the commercial job sites. So for the residential stuff, we said, okay, if they're already dumping it in this spot, let's go next to that dump pile, right? We've got these aggregate companies that are already collecting all the material. Let's go put our machine next to that pile of wood. And so as all the contractors are dumping their material there, we're going to be there cleaning it and then again, ship it out of there on flatbed trucks.
One more follow up, if I may, then,
Yeah.
Sabira, of because what I'm uniquely fascinated by is I love that evolution. That was a quick evolution to okay, this thing needs to be mobile. It can't be within harm's way of debris in some of these facilities. That then calls next sort of the question of the sales model that I'm kind of curious about, and that too will evolve and has already likely evolved. Can you talk a little bit about that evolution of where you all were thinking, hey, this is where this value might actually be placed in the supply chain, and then maybe where it's headed, and then probably mixed in there too a little bit of the unit economics. I love that you said you placed it near the grinder. That is clearly showing that, okay, grinding up the wood is one set of lower unit economics where it becomes maybe a mulch or some sort of wood-based material used for something industrially. Well, what does it do to actually reclaim that? How does that affect the unit price? So my two-part question in there is really sales-based and then unit economics-based.
Yeah, absolutely. So on the sales side, our target is lumber industry, wood manufacturers, and there's a range of prices that we can charge for it,
Yeah.
right? If I've got like a large dimension old growth beam, I can be 5, 10, $20 a board foot. If I'm a 20-year-old 2x4, I'm probably 35, 50 cents a board foot, right? So there's a huge range there, and we
Right.
don't have control over the feedstock. But what we do have is we have cameras that are looking at the feedstock. So we can make sure that that high value old growth material goes to the right customer, right? So we can have a sales model to them. And so we're going to be selling lumber just like the lumber industry does, per board foot basis, dollars per board foot, truckloads is going to come out of our machine. And that's how we're going to do it. And
I
so our
love that.
unit economics is at the end of the day, there's people that will pay a green premium, right? There's people that pay more for reclaimed lumber because of the age, the story, the carbon storage capability, all that great stuff. But then if I go down into, we'll throw our buddies in Texas under the bus here, they don't care, right? They just want the cheapest thing in the world, right? And so at the end of the day, I have to compete with virgin wood. And so we use the virgin wood mill price as our competitor that says, hey, if I have to go head to head, this is what it is. And so the target of our machine is to build a clean, reclaimed lumber and compete with a virgin lumber mill. That is our North Star that we've set for ourselves. And we've done it for the 2x4, which is the highest volume dimension out there on the market because every house and building has been built with those for the last 100 plus years. And it's got the highest number of fasteners per board foot. So not only is it the cheapest piece of material out there, it's got the most expensive for us to clean. And so that is the engineering team's North Star. We're not there yet, but we're getting there. We're hoping to be there next year. For the machines, we'll be leasing these machines out next year when they come out. So we're going to start a small scale production run, build about a dozen systems in 24, get those out to about 6 different major metropolitan areas, and get them operating, get them out in the field, get them in customers' hands, getting them using them and giving us feedback on it. And our goal there is I don't want to leave my customer with old technology. We're going to iterate again. We know we're going to keep iterating on their feedback. So we're not going to sell them. These machines will end up back in our shop and disassemble and rebuild them. Hopefully we can reuse the frames and everything. But they'll get upgrades, right, after they spend a year or two in customers' hands. And so that's going to be our model next year. And so we're currently working with essentially a metropolitan region. And in that region, we're looking for sources of material. So the demolition decon contractors, the waste facilities, we're looking for an operating partner. So who's got a big piece of dirt or a warehouse we can drop these machines in. And then who are going to be the customers that can consume that material. And then in some regions, we're working with the government agencies who have deconstruction ordinances and waste reduction ordinances. We've actually found some of those folks to be some of the best sponsors of what we're looking to do. And then they bring everybody else together for us, which is awesome.
We know those conveners well. Those in the public policy world that are passionate about this and can bring the voices together. Thanks for that. Yeah.
I'm curious about, you were mentioning like iterating on the technology and working with your engineering teams. Paint us the picture of your product development life cycle and how often you iterate, and also how dependent you are on how fast AI and computer vision technology is moving to make the progress towards the North Star that you want to make.
Yeah, so there's the two pieces, right? We've got the hardware component and the software component. And the software team, every week they release a new update, right? They're constantly training data, constantly updating the model. Theirs is a very quick cadence. And the big advantage to the software team is when they do an update, they just push a new version out and update the data set and off we go. Unfortunately, the hardware team, when they do a new update, we take a system, we put it in the corner, and we have a whole new system in place. We are currently assembling our 5th hardware iteration in 2 years. So, in 24 months, so about every 4 or 5 months, a new version of the system comes out. And it's pretty phenomenal changes to it that we make on a pretty rapid cycle for hardware. So, and a new version comes out. So that's new motors, new brushes, new pickers, new pullers, new pneumatics. Whatever we learned on the last system goes in that next version. And so imagine going from what used to be, our very first one was like a tabletop, benchtop prototype with a webcam on it, to this new, highly sophisticated electrical boxes. You'll see it in the pictures that we share with you guys. That's currently running through testing in our shop. And there'll be another one of those end of this year, early Q1, that'll come out before we start that production run. And each one of these systems, is a couple $100,000 worth of hardware. And so to set that aside and release a new version, it's it's tough, but it's what we have to do. It's what we have to do to keep pushing the hardware and the limits of the hardware, and we find out which vendors work, which ones don't work. But you got to move quickly. You got to keep iterating on this, and that's why startup and robotics and R&D work. You will not find this in a general contractor or a large corporation. Because as soon as one of their CFOs found out that you were spending a couple $100,000 on a machine that only lasted 4 to 5 months, they'd have a heart attack. They would just seize up and jump out a window or something. That's why you can only do this in the startup world.
Well, tell us also how you capture that feedback from the customer, because there's the software piece and the hardware piece, and identifying, are they capable of really identifying what the issues are and how do they communicate with you? How often? How are you able to move so fast in making those iterations?
Yeah, so right now we are our own customer. We're operating the machine. It's our labor forces that are feeding it material. And so as soon as it breaks, it's our engineers that are out there fixing it. And so that's been super critical to it. And this is something I learned at the previous company I was at when I was working with other robotic startups. You got to operate the equipment yourself. Bring in your own labor force, your own tradespeople, get that machine running, doing whatever it's supposed to do. Because as soon as there's a bug, your software and hardware engineers immediately have access to it. They're your employees. They're going to tell you exactly what's wrong with it, and then you can fix it real quick. Our machine went down yesterday afternoon. My co-founder Andrew was up there this morning swapping out components, and it's back online a couple hours later. But we know exactly what parts failed. We know the vendor that failed us, and we know we got to swap that part out.
I love that feedback loop question. It kind of brings me to think about the problem that we're actually solving. And one is, I'm dealing with this right now with loop layer of these problems that are almost sometimes future problems. These we're solving things that we are predicting are going to happen, which is a deficiency of supply. We need to address some sort of market for a lower carbon from a lower carbon perspective. I would love your perspective on this. I mean, clearly we're wasting too much wood. We've been doing that for probably centuries. But at this point, even the flow is not sort of diminished in any way, and we can start to reclaim that wood. From what I understand, that is an opportunity for feedstock. But some of what that actual problem is, to your point, is getting a robot to be able to do that task of denailing. But can you speak more to the problem, I think of which I maybe even learned from you earlier in an earlier conversation, which is the problem is that when reusing the wood, how much of a danger it is to have lodged pieces of metal in that wood. And that ultimately can really decrease the ability of that wood to be used. Can you speak more to that problem?
Yeah, so the challenge with wood is when you're going to use it, you typically sell it to somebody that's going to process it. And you don't know exactly what they're going to do with it, right? They're buying a raw chunk of dimensional lumber from you, and they may use it perfectly as is, or they may drill holes in it, or they may cut it in half. And all those tools that they're using, from the drill bits to the saws to the planers to the sanders, are not expecting metal. If they hit metal, that's chipping teeth, that's breaking blades, that's breaking a process line. That's an unhappy customer, which we can't have. We've got to make sure that the wood is clean. And we're not the only ones with this issue. The virgin lumber folks have the same problem because they're harvesting trees that have been growing in a forest, roughly 20 to 80 years, depending on what they're foresting. But there could have been fences and bullets and signs that have gotten stuck in those trees. And so the virgin lumber industry has the same risk as well. They have to check for metal in trees before they run it through their sawmills. Because if they hit one of those chunks of metal, somebody hung a piece of barbed wire up there, it gets wrapped around a machine, that takes that machine offline. That's a lot of money down. And so they're doing similar things. So we're doing it because we know it's there. 100% there's metal in the wood we process, so at least it's a known for us. For them, it's one in every so many trees is going to have a chunk of metal in it.
I love that idea of a known problem. Yeah.
Yes. I like known over unknown, right?
Yes.
We know it's going to occur in every piece. So it's an interesting problem. And when we were researching this problem a couple of years ago, we went up to Oregon to go visit some lumber mills and understand their workflows and how they process virgin trees and the woodworking manufacturers. And one of the woodworking manufacturers had his wall of shame, and he showed us all the metal. So think about this. The metal made it through the lumber mill, got turned into a raw dimensional lumber, and then he was turning it into finished products, and he hit the metal. So telephone wires from communication, barbed wires, bullets, metal signs, all this stuff was inside the wood. He had this on a wall, and he'd be running, I think, 30 or 40 years his business. And that kind of really sunk the point home for the team. It's like, okay, guys, we gotta get the metal out.
And working with known problems, what a joy.
Yes, exactly.
What about the quality of wood? Do you see that changing also over time? We were learning in one of our previous conversations about how the growth of trees because we're doing it so fast in order to use the wood faster in order to keep up with production at the rate that we're building buildings, that the quality of wood is not as strong. Do you see that as being a problem economically for you in the future, or just like this, that the source of wood and the type of wood is going to change and how that's going to matter to your
This
business?
is this is all I ever want. I want
This is what you
examples
want to
like
see.
this.
You want
This
examples,
is
right?
great.
So if you see on
Yes.
top, so this is old growth, tight grain.
Yeah.
This is probably second gen, and this should be third or fourth gen down here in terms of forest harvesting.
Oh, so look how dense that top
That
grade
top
is.
one is, right? So that gives you an idea. So this was, nobody had been in the forest until a logger showed up and took down a tree that was probably a couple hundred years old, to give you an idea of the delta between these three. And then obviously this one on the bottom is within the last 10, 20 years type of thing from more of a tree farm scenario. Um, so the cool part about that is the material we're saving is phenomenal in terms of quality, right? What we're processing, the older the material, higher the quality you get. And so that goes back to making sure we divert that to the architects who pay premiums for that material, right? That tight grain shows up really nice in wall panels and architectural stuff. And it's really strong, very few knots, so it's got great strength characteristics to it. But today's wood still has good strength to it, right? It still meets grade, it's holding up buildings. It just doesn't have that dark brown, tight grain color to it, and it's got a lot more knots in it. And so that's where the engineered products come in. And so a lot of that newer wood that we're processing, we call it about 0 to 60 years kind of thing, will end up in a product that we're partnering up with another company on called Dow laminated timber. And so if I take a bunch of material that doesn't look quite as nice, I can turn it into engineered panels. And I can make walls and floors and these
Hmm.
assemblies where I can use my wood milling processes to make it look much more attractive, which is cool. And so we'll have a pilot plant kicking off here in December at the same lumber yard we're currently at that'll produce Dow laminated timber panels. And the cool thing about these DLT panels is not only that they're going to be made with reclaimed lumber, but then at the end of their life, you can take them apart and you can build another panel because it's all wood to wood connections. We use way less glue than the CLT folks, so you can disassemble the whole panel.
How does the machine actually, and how are you training it in a lot of ways to deal with the various densities? I'm curious how it registers that density via some sort of imaging, whatever that might be. How does it actually understand, okay, this one's going to be a little bit softer than that 100-year piece of wood. I can treat it like this so I don't snap it in half or do something that's going to absolutely just jar up and jam up the
Yeah.
machine.
So we treat them all the same. We treat them all the same. We have to hold the board in place while we're pulling on it, because you've got two things. You've got the board strength, right? The friction force on the fastener, and then you've got the fastener itself. So think of a 16 penny nail that will bring our board back that goes through the board and then bends over 90 degrees. When we pull on that, it has to straighten itself out and come back out the top of the board. So we're pulling with about 700 pounds of pull force.
Mm.
And we have to do that on an old growth piece of wood, which is that hard, tight grain. And so that's what we've done is we just said, hey, look, we got to get these fasteners out. And the great thing about wood is it's incredibly resilient. It is a high strength natural material. And so you'll see the wood in our machine bend as those nails are pulled, and then the nail pops out and it whoop, deflects back to straight. And so it's pretty cool. But yeah, we've tested the limits of wood and holding it and how far apart do our clamps need to be to make sure we don't break it. And once in a while, a piece breaks. We'll find there's a knot in the middle with a big crack through it. There's a void in that wood, and it splits. Good
Yep.
news is it doesn't happen often.
Right.
I'm curious about you mentioned kind of your expansion plans of going into a metropolitan area, working with an operating partner. If you had somebody listening who's a wishful operating partner, what would they expect on how to work with you? Will you be leasing the machine to them and giving them the know-how of how to operate it? How much can they count on your expertise and knowledge in the area? Were you ever thinking of franchising? Kind of what were the options on the table and what's the plan right now?
Yeah, so our goal is to train. Obviously, we want to make them experts. And so what we're doing this year is we're making ourselves experts, right? We're out operating the machine. We've got our own crews. We're going through all the logistics and support and infrastructure that goes with it because there's obviously operating the machine. But then what's that whole workflow process look like, right? How do you take piles of lumber and organize it and feed it and process it and clean it and stack it and label it and print it and put QR codes on it? So we're doing all that this year. We're getting that whole workflow process ironed out ourselves. So when we start training customers next year, we're going to be like, okay, here's the best practices from our side. Here's what we learned. Here's what works. Here's what doesn't work. And then maybe they'll even find a better way. We'll be completely open and honest with them, but we'll say, hey, this is at least a known set of best practices that we've executed on for the machine and to get them up and running. And then we're looking forward to them coming back and telling us, hey, here's things we can do better. And part of that is we're doing pilot projects here in the next 2 quarters at waste facilities. So we're actually going to go drop the machine in waste facilities and operate with their teams and their equipment on their facilities and test those workflows out with 3 different ones, a small, a medium, and a really large one.
Looking into the future, what are you really trying to expect out of this market in terms of growth? Sabira and I are often asked about different market growth opportunities and how to expand it, how to measure this. What do you all talk about in terms of what this? I'm not going to get too much into the TAM, SAM, SOM, all those for those that have sort of investor mindsets. But ultimately, as the market grows, what do you see? What are you addressing now? And then what do you think this would look like in the future?
Yeah, so our measurement is board feet, right? How many board feet of material are we diverting from one of
I
these
love
current
that.
sources into new buildings or furniture or whatever it is, right? So our economics is all about the board foot, which to be honest is an awful measurement. It's
I
a
was going to say,
funny,
I actually really like that. It keeps it very simple. Yes.
it's simple, but it's it's a board foot is a 1 inch thick, 12-inch wide, 12-inch long piece of lumber, right? It goes along with the inch and foot disaster that we have here in North America as well. Whereas, I can do cubic meters over in Europe. Hey, it's much easier, right? We're using board feet here in North America. And so, I mentioned early on the 37 million tons. Well, that's equal to about 37 million board feet of lumber that gets thrown away every year in the United States. Um, and so, what our goal is to recover half of that, and recovering about 37 million tons is 37 billion board feet. Covering half of that is about 18 billion board feet of material that we want to divert. And so our goal is to hit that over the next 10 years here in North America. And then obviously expand and go international because Europe's got the same issue of going to Australia, New Zealand. We got folks from all over the world reaching out to us like, when can we get one of these systems? Which is a great problem to have. But that is really at the end of the day, we've created a business. We've created these essentially mini manufacturing processing facilities that are cleaning up this material, creating these local supply chains, and we're reusing this material to build new houses. If you think of housing affordability, it's tied to the price of wood, as we saw during
Well,
COVID.
and I love the way that actually works out from a future economics perspective because that makes it very reliable in terms of thinking. Okay, that's very much treating it like any sort of commodity. You've mentioned that mission in one of the questions previously, which is you got to compete with the virgin lumber industry, and so ultimately that commodity value will, as I'm betting on, will go up, and it will no longer be thought of as a premium but a necessity, and then there will be another premium market on top of that to some degree. And so that's a very interesting, I think, way to look at whether that's the board feet or any other type of metric system.
Yeah, I mean, if it does, I don't think we'll see a spike up like it did during COVID, where it was four or
Right.
5x its traditional value, but it's going to go up, right? As the planet
Right.
grows and we have more people, we need more housing, we need more buildings. There's not enough forest there to supply it. And we need to find lower carbon solutions than steel and concrete. And wood is a great one. And so we're closing the loop on wood and making a circular product like steel and concrete, but with a much lower carbon footprint to begin with.
I'm exhausted of questions. This is again, I find so much joy in talking about these solutions. Sabira, please round us out, and Eric, if you have any questions for us.
Well, I was going to say thank you so much for identifying this problem and chasing it and spending your life trying to solve it, you and your team. I think it's really inspiring. Do you have any last words for young entrepreneurs who are thinking about venturing into the circular economy and building a business around it that is profitable and can sustain a life?
Yeah, look at our waste streams. We're solving one piece of the waste stream, right? Now it's a large piece. I think construction debris makes up something like a third of landfill waste, with wood being about half or a third of that. So we definitely took one of the larger challenges out there, but there's still many more to go, right? There's still a lot of materials. You look at insulation materials and plastics and glasses and all these other materials that are either going to our landfill or getting severely downcycled to a next one. And so we need more folks to go target these physical materials because one, they're massive problems. We need to stop throwing stuff in the landfills. And two, they can be turned around and go back into the buildings, right? The best thing we can do is get to a point where anytime you remodel or take down a building, all the materials separated out, it's cleaned, and it has a reuse path. So it never goes to an incinerator or a landfill. That would be like a North Star for humanity if we can do that.
Well, everyone we talk to, Sabira, we keep saying the same things. It's aggregation, sortation, and finding that end market. And so, again, I think if we just keep hitting that home for our audience, we keep hitting that home for any of these entrepreneurs that are, to your point, looking at these waste streams, well, there's a bright future ahead for us. Eric, thank you so much for taking the time. It's, again, another pleasure to talk to you, and we look forward to tracking this company and tracking you all as you grow into salvaging the past to build the future.
Awesome. Thank you very much, Gar and Sabira. It's a pleasure to be on your show.